Okay, guys, now I'm going to explain the other kind of exercises. There were two types. The first one is whenever I'm giving you 3 points of a parabola. For example, the problem says, determine the general equation of the parabola whose axis of symmetry is parallel to the x-axis and passes through the points P, -1, 1, Q, -1, -1, and R, -5, 0. Before I explain the problem, guys, we need to take into consideration the following situation. Whenever I'm going to find the equation of the parabola that passes through 3 points, I have two options. It's either a parabola that it's horizontal or it's a parabola that it's vertical, okay? Every time my parabola is horizontal, this is the equation that I'm going to be working with. And whenever my parabola is vertical, then this is the equation that I'm going to be working with, all right? Horizontal, guys, it's like the one that we have here in this picture. So if we have something like this, we would use y squared plus dx plus ey plus f equals 0. If my parabola was opening upwards or downwards, that's when we use x squared plus dx plus ey plus f equals 0. So now, with that in mind, let's go back to the problem. We know that if it's parallel to the x-axis, then that means if I trace these points, these red points, this one, and this one, are these points that I'm giving you. I know, guys, because it says that the axis of symmetry is parallel to the x-axis, I know that the parabola is going to open this way and it's horizontal. So with that in mind, then I know that I should be using this equation, y squared plus dx plus ey plus f equal to 0. So what are we going to do now, guys? We're going to take those 3 points and we are going to substitute into this equation. So we substitute to get 3 equations. We take the first point and we substitute y's, 1 in y's and -1 in x's. And then I have my second equation, which I'm going to substitute -1 in y's and -1 in x's. And same thing for my third equation, I'm going to substitute 0 in y's and -5 in x's. With that, I have these 3 equations. I simplify this, guys, and I end up with 1 minus d plus e plus f equals 0. The second equation would be 1 minus d minus e plus f equals 0, and my third equation would end up being minus 5d plus f equal to 0. I have a system of 3 equations. So now I'm going to eliminate one of the variables of these 2 equations. Which one am I going to eliminate? I'm going to eliminate e, guys, because then I have to combine that new one with the one that I'm missing. So if I add 1 plus 1, I get 2. Negative d minus d, I get -2d. E minus e is 0, and f plus f is 2f. And 0 plus 0, 0. And now I take this new equation and I take this one that I'm missing that I haven't used out of the 3 equations, and now I need to eliminate another variable between these 2. I'm going to eliminate, in this case, letter f. To eliminate f, guys, I need to multiply this equation by -2. So if I multiply -5d plus f equal to 0 times -2, I'm going to end up with 10d minus 2f equal to 0. I add these 2 equations because I'm doing it by elimination, and I get 2, 10 minus 2 is 8d. The f's go away, and 0 plus 0, 0. And then from here, guys, all you have to do is isolate your d. The 2 goes subtracting, and the 8 goes dividing, and so I get that the value of d is -1/4. With the value of d, I can go back and get the value of another variable. So now, what I do is I take this third equation, which is the easiest one, and I substitute in d the value of -1/4. So I have -5 times -1/4 plus f equal to 0. And I isolate for f. So -5 times -1/4 gives me 5/4 positive, and then if this is adding, I take it subtracting to the other side, and I get that f is equal to -5/4. Now I have f, and I have D, I'm only missing E. So I take any of these two and I substitute the values of D and F to get the value of E. In this case, I substituted in the first one. So I have 1 minus 1/4 plus E plus minus 5/4 equal to 0. I isolate the variable of E from here, guys, and you get that E is equal to 0. Okay? Okay, so now with the values of D, E, and F, because that's what we got. We got that D is negative 1/4, E is 0, and F is negative 5/4. And I know that this is the equation that I'm using, y squared plus dx plus ey plus f equal to 0. I substitute the values of D, E, and F with what I got. So I have y squared minus 1/4 of x plus 0y minus 5/4 equals 0. And now I need to get rid of the denominator because I need to make it look in the general form. So I multiply everything by 4 and I get 4y squared minus x minus 5 equal to 0. This is my general form. Now with the general form, guys, I can find everything else. If I put this in the ordinary form by isolating y squared, I get that y squared is equal to 1/4 times x plus 5. Whenever I get it this way, guys, I know that k is 0 and h is negative 5. So my vertex is minus 5, 0. The value of p, I need to equal this to 4p, and I have 4p, it's equal to 1 over 4, and I get that it's 1 over 16. If to negative 5, here at negative 5, I subtract a negative 1 over 16, I will get the focus, which is negative 79 over 16, which is approximately minus 4.94. And the directrix, which is on the other side, it's on this side of the vertex, then my directrix would be minus 81 over 16, which is approximately minus 5.1. Okay, the lattice rectum is 1 over 4, so that means that if I divide 0.25 by 2, I would get 0.125, and that's the distance that it should be from the focus to the point on the parabola and from the focus to the point on the parabola, approximately 0.125. And with that, I have now all of the elements of the parabola.